All right, here we go. Unit 9, Section 1, Polygons and Perimeters. So a lot of words in this section, but it lays kind of the foundation for the entire unit. So a polygon, first of all, is a figure that meets the following. Number 1, it has to be formed, by 3 or more sides that don't cross. And also, it has to be a closed figure, so no open ends. That's all that means. There are two types. We have convex, which is if no line contains a side. No line that contains a side on the interior of a polygon. Okay, then it would be convex. Concave would be a line that has a point on the inside, or a polygon that has a point on the, it's not going to fit there, on the interior. Polygon that has a point on the interior. So, jumping down here below, tell whether each figure is a polygon. If so, is it concave or convex? So first of all, yes, this is a polygon because it has 3 or more sides, no lines that cross, and it's a closed figure. So what kind would it be? This would be convex. There are no points on the interior of this polygon. There's no angles like going inside, pointing inside. Number 2 here, yes, this would be concave, because you can see here this point and this point are pointing inside towards the middle of our polygon here, and it's 3 or more sides, closed, nothing's crossing. And the last one would be no, because we can't have a gap. Everything has to be closed up. So the types of polygons, I'm going to kind of go through these quickly. We'll try to use this vocab as we go throughout the unit, but some of these you already know. If you have a polygon with 3 sides, we call that a triangle. A polygon with 4 would be a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. I'm going to try to keep these lined up. 7 sides would be a heptagon. Not a very common one. 8 sides, octagon. 9 sides would be a nonagon. Nonagon, sorry. Help if I could spell. Not a very common polygon. 10 sides, we call that a decagon. Then we skip 11, we go right to 12, and that is a dodecagon. And then if you have 11 sides or 13 or more, we would just say that's a n-gon. So for example, if I asked you to name this 17-sided figure, you would just say it's a 17-gon. If it was a 21-sided figure, a 21 gone. That's all that means. You just replace the number with n there. Okay, so a couple other things here. Equilateral polygons. You know what an equilateral triangle is? Well, it applies to all polygons. That just means all sides are congruent. That's all it means. Equiangular means all angles are congruent. And regular is here's the key, convex polygon, which means if you go back up, there are no, we don't have this situation going on. We don't have any angles pointing inwards. Everything's pointing out away from the middle. Convex polygon that is both equilateral and equiangular. And we'll spend a lot of time talking about those here in just a second. So here are some visuals for you. The first one's equilateral. The second one would be equiangular because not all sides are the same. And the last one would be regular. So some other prior knowledge here quickly, and then we'll do just one or two examples. Perimeter is just the distance around a figure. So you just add up all the sides. And the circumference, which math is weird like this. Why can't you just call the distance around a circle perimeter like everything else? But this is specifically for a circle. Distance around a circle. All right, so an example, we have a rack for a billiards ball. It's an equilateral triangle if you didn't know, it's a fact. Find the value of x and then the lengths of the sides. So here is the key. Here's where the vocab comes in. It's equilateral, which means the sides are the same. So if you want to set up an equation to solve, you would take one side, 4x plus 2, set that equal to 6x minus 4 because both sides are equal. All three sides are equal. We first have to find x, and then we'll plug it back in to find the length of each side. So we'll start by subtracting 4x. So we have 2 equals 2x minus 4. We'll add 4. 6 equals 2x. And last but not least, x equals 3 if you divide both sides by 2. So that's the first part. Now if I want to find the length of a side, you pick either one. I don't care which one. I'm going to take that one because there's no subtraction involved. So if I want to find the length of a side, I take 4 times 3 plus 2. 4 times 3 is 12, plus 2 is 14 inches. That is the length of each side. Excuse me. So the last example here, the expression 3x plus 5 represents the measure of each side of a regular pentagon. So a pentagon means it has 5 sides. Regular means all the sides are the same, all the angles are the same. Find the measure of each side of the pentagon if the perimeter is 85 feet. So how do you find the perimeter? You'd add up all the sides. Or you could just take the number of sides, which is 5, times one side. It all does the same thing. Set that equal to the perimeter. If you distribute here, 15x plus 25 equals 85. Now we're just going to solve this using some algebra. Subtract 25. 15x equals 60. Divide both sides by 15. X equals 4. Oh, how about x equals 4, not x? Okay, so you found x, but now it says find the measure of each side, or find the measure of one side. So 3 times 4 plus 5 would be 12 plus 5, or 17 feet. So there you go, using the idea of perimeter and some vocab like regular, and then pentagon, octagon, all kinds of words like that. So get used to seeing those words. We're going to use them quite a bit in this unit.